Landslides are one of the major natural disasters which affect large section of the population in heavy terrain, directly or indirectly. The major widespread landslide events of 2013 in Uttarakhand, 2018 in Kerala and Karnataka, 1968 and 2015 events in Darjeeling, West Bengal reminds us the loss of hundreds of lives with extensive damage to property, infrastructure and impact on livelihood.
GSA declared as a nodal agency for landslide. About 12.6 Indian landmass is prone to landslide in our country, covering 0.42 million square kilometers. Landslides are triggered by rainfall, earthquake and anthropogenic activity. In India, majority of the landslides are triggered by rainfall.
GSA executed Memorandum of Understanding with the British Geological Survey of the Natural Environmental Research Council, subsequently signed implementing arrangement for developing of regional landslide early warning system.
The geology of the Himalaya is quite immature, very complex vis-a-vis the geology of the Western Ghats. If you find it is quite a mature topography.
However, different predisposing factors and equal rainfall causes large number of rainfall-induced landslide events with varying magnitude, type and impact.
Now in this area, Geological Survey of India has done extensive research and extensive work since the last century.
The idea of using that knowledge and expertise and translating that to our colleagues in India was how landslides started to develop. So our relationship with the Geological Survey of India and then the Met Office's relationship with the Met Office in India, and how we could do something similar out there to show how we can use knowledge to then translate that forward for landslide early warning in India. Landslip is about ensuring better preparedness for landslide early warning in India. To do this, we're working in collaboration with various partners to share our knowledge and experience and work together to co-produce an early warning system.
The research comprises of 7 interlinked work packages. Work Package 1 and 2 on management, project coordination, co-production, outreach, uptake and sustainability. Work Packages 3 to 6 focus on knowledge, tools and methodologies contributing to a landslide multi-hazard framework through these dynamics. Work Package 7 integrated landslide risk assessment and early warning system in a multi-hazard framework for optimizing tools and methodologies. The consortium brings in the domain experts from geologists, geomorphologists, social scientists, meteorologists, computer professionals under one roof. The collective ambition of this consortium is to contribute to better landslide risk assessment and early warning in a multi-hazard framework, and by working with national and district authorities for better preparedness. The pilot study areas are in 2 contrasting terrains of India: the rugged Himalayan terrain of Darjeeling, West Bengal, mature landscape of Nilgiris, Tamil Nadu. Both pilot areas are landslide prone with population densities from very few to over 600 per square kilometer. Both have experienced past events with fatalities and socio-economic impacts. Both experience intense rainfall during the northeast monsoon, which trigger landslides.
The system uses daily meteorological quantitative graded forecasts of precipitation from National Centre for Medium Range Weather Forecasting.
Met Office UK has developed a landslide decider tool to identify the high-risk weather regime responsible for landslides in the area.
A rainfall threshold is represent a condition, the rainfall condition that when reached or exceeded is likely to trigger a landslide. Rainfall threshold can be defined at about using empirical approach or physically based approach.
CNR defined an algorithm to automatically reconstruct the rainfall condition responsible for landslide. The well-established frequentist method is used to calculate the threshold at different non-exceedance probability and its associated uncertainties. Forecasting of landslide is possible with the prediction of hydrological condition responsible for landslide.
Within landslide, we developed and implemented prototypal landslide early warning system algorithms to forecast rainfall-induced landslide at daily to seasonal scale.
The algorithm estimates how likely a given rainfall condition characterized by duration and cumulative rainfall will trigger a landslide. Such forecasts are used to predict the landslide occurrences in next 24, 48 and 72 hours.
Susceptibility map shows the spatial probability of the landslide in the given terrain condition. In this research, we have prepared three kinds of susceptibility map: susceptibility for shallow slides, for rockfall and for the debris flow, to use it in the early warning system.
Dashboard is prepared to visualize all the maps and forecast on single platform. It is a map-centric tool for visualization of temporal and spatial data.
Validation is an essential part of our work because it helps us to assess the uncertainties of our models, in particular for landslide forecasts. That is why we need systematically to collect information about the occurrence of new events. For that, remote sensing and image process can help, but unfortunately in our test areas, the persistence of cloud does not allow us to use optical images. That is why we are fostering the use of all-weather SAR images to detect landslides.
At GSI office, the landslide team will daily assess the landslide information on dashboard in daily basis. By integrating landslide forecast, slide susceptibility, susceptibility for debris flow, landslide incidences and other supplementary information, the landslide bulletin is being prepared. The bulletin will be disseminated from GSI office to the stakeholders.
In GSI, we are looking into integrate both the top-down approach, what we are getting from landslide, to the bottom-up approach, what we call a community science approach or a public or a people-centric early warning system.
Public participation, including community awareness program modules, will be the backbone of the system for effective reduction of landslide risk. GSI plans to develop a landslide early warning center and extend the study in Uttarakhand in participation with Indian agencies.